And as usual, thank you so much, Augusto and Eduardo, for organizing and setting the meeting. So Rosa, whenever you're ready, it's all yours.
Okay, thank you. Thank you very much. Thank you, Sandy, and thank you, Augusto, for your invitation to be here. And it's my pleasure to present some of my research. I'm not sure if you are hearing me correctly because we have talked today and my voice is not very good today, but I hope to make me understand. Okay, I would like to present this work that we are at this moment developing with my colleagues, Sara Miranda and Cristina Sarasa from my department, the Department of Economic Analysis in Zaragoza. And we have entitled something like Household Consumption Patterns and Income Inequality in the European Union countries. Something about scenario analysis for a fair transition to low carbon economies. More title than work at this moment, but in any case. Okay, the outline of the presentation is the usual. I will briefly motivate the study. I will talk about the methodology that basically is the use of a multi-regional input-output model, and they move to the results. We have two types of results. First, we are looking backward to the recent trends in Europe. For this, we will use a structural decomposition analysis. And then we will try to look forward using a type of scenario analysis. And I will conclude with some final comments and final remarks. Okay, let me talk about the raising awareness of the current and the future consequences of climate change in the world. And all this has led to a lot of international commitments aimed at ensuring this sustainable development. For instance, the framework, the United Nations Framework Convention on Climate Change, the Paris Agreement, and specifically the United Nations has adopted a set of goals trying to end poverty, protect the planet, and ensure the prosperity for all the people as part of this strategy for the new sustainable development. So we have two types of objectives. On the one side, the Paris Agreement is pushing to obtain a global action plan to try to reduce emission and limiting the global warming to below 2 Celsius degrees. And on the other side, we have also the 17 Sustainable Development Goals. And here we find the goals of reducing inequality and poverty. We have goals about achieving a responsible consumption and production, and also a claim to climate action. In this general world context, the European Union is also playing or aims to play a crucial role in the path to obtain a sustainable development, and has put us as a particular objective to obtain a carbon neutrality in the European Union by 2050. And several institutions have, as the European Energy Agency, have acknowledged that all this process needs to look beyond the isolated efficiency improvements that we have had in these years, and instead we have to address the production and consumption system in a whole vision. And in other words, there is a need to put our production, distribution, and consumption patterns in the line of a sustainable path. And in this path, or in this trajectory, the European Council recently recognized that although we have, the European Union has had some progresses towards these sustainable consumption and production patterns, we are in the low ranking in the United Nations regarding this objective. And also, despite the positive progress and the scores on some of the other sustainable development goals regarding the end of the poverty or the reducing inequality, there are still important differences between and within the member states. So we have a pending task regarding in Europe regarding this consumption and production patterns to sustainability, and we have also the issue of reducing poverty in Europe and also reducing inequality in Europe. So in this general framework, we want to use our usual instruments of analysis to study the relationship between the production and the consumption systems and the environment and the lifestyles, and this goes to the carbon footprints of households. And here we want to study some trends in the inequality of the carbon footprints, but also to focus on how to study the role of income distribution, the changes in the consumption patterns, and the changes in the technological conditions in Europe and worldwide. And we are going to use the multi-regional input-output framework, and we are trying to use a scenario analysis to provide some intuitions and some guidelines for the compatibility of the sustainable development goals. So as I have said, this is an ongoing project that we have started to see and to study and to obtain the first result. Okay. Basic literature, you know that the carbon footprint of household from a consumption-based perspective has been widely studied in these last decades. We have, for instance, the works of Turner, Lensen, etc. But one important, although less studied issue is the role of income and income inequality in the relationship and the relationship with the environmental footprints, although we have some of the, we have some words in this slide. From this literature, we have obtained some important ideas or some relevant insights. For instance, that the disparities in income distribution and lifestyles, and together with the different production technologies, represent a different starting point for the countries to reach their environmental objectives and to meet the international commitments. For instance, Huba had found there is the great difference between the top 10% richers in the world that were responsible for more than 30% of the total carbon emissions, while the poorest part of the population only contribute 4% of the total global emissions. We have, for instance, that in the US, first and poll show that the richer household in the US pollute 5 times more than the poor households, and these differences were explained not only by the scale factor, the income, the total income and the total consumption, but also by the consumption patterns. And regarding the end of the poverty, some authors have said that there is a trade-off between the environmental objectives and the environmental goals and the economic goals. And for instance, Hubahet and others show that if they want to, or in the case of reducing the extreme poverty in the China and India, the carbon emission would increase by 4% and 70% respectively. And also other authors talk about the trade-off, this trade-off between environmental conservation and income inequality in the short and in the medium term. So with all this, or in this basin, in this literature, we want to understand the relationship between these components of this variable, for instance, between income distribution, between the consumption patterns, between something about lifestyles, technology, etc. And for doing this, we are going to combine the supply side and the technology part and the income part, etc. In the economy. We are going to use a multi-regional input-output model. I assume that you know the multi-regional input-output model. So this is the usual equilibrium equation, equation 1, and equation 2 is the representation of the equilibrium in the economy on the basis of the Leontief inverse. And you know that this is the representation of the equilibrium in the economy, the economic part, and we can extend this model considering an extension, a vector, for instance, of CO2 emission intensities or water intensities or whatever you want, and we can obtain with the Leontief inverse the pollution values or the pollution coefficients of the pollution multipliers, where each representative element in this lambda will tell us the pollution generated in the economy, and directly and indirectly incorporated in the inputs need to produce it unit of final demand. Okay, so this will be our environmental extension of the model, and we are going to focus just in one part of the final demand. We are going to focus on the final consumption of households in the countries, and this final consumption we are going to split this demand by income categories. So, and also once we have this final demand of household by income categories, we are going to identify different components. So at the end, the total emissions in the economy linked to the consumption of household in a countries and in all the countries can be obtained as a combination of three components. One that will represent the technology, that will be this representation of the technology in a broad sense. We have also an indication of the consumption by income group, the consumption pattern by income group. We have also an indicator of the consumption by income, the total consumption by income category. This will be our approximation to income distribution. And we have also a scale component that will represent economic growth. And if we want to evaluate the changes in all these emissions associated with households activity on time, we can observe, or we can distribute these changes according to the main components that we have identified. And for this, we use a typical way of analysis, that is structural decomposition analysis. And more specifically, and according to the proposal of Dietzenbacher and Loss, we are going to represent the two-polar solution, and we are going to do the simple average of the polar solution as is usual. And in that case, we can identify the main components affecting or within the main components affecting the changes in this total emission associated to the evolution of households in Europe. And we can talk about technology, we can talk about the changes in the consumption patterns, changes in income distribution, and also this evolution, economic growth or evolution of consumption in Europe. Okay. Our main database is the EORA database for this study. You know that EORA database provides a multi-regional input-output data with environmental accounts for the world economy, and this information is combined also with information on consumption expenditure structure that is obtained for Europe from Eurostat by for 5 income groups. and we are going to do the analysis for 2 periods in which we have information. We have information on the consumption structure that are the period, well, these 4 periods that you have here. For this presentation, I will only focus in the total change from 1999 to 2015. Okay, first, are relevant the household for the global emissions associated to the demand in Europe? The answer is yes, because if you see here, this is the participation of households in the total embodied emissions, and households account for more than 60% of the total embodied emission associated to the final demand in the European Union, and is the most polluting component of the final demand, although we can observe a slight decline in the share in these 15 years. So we are going to apply the composition and the methodology that we have explained, and I'm going to summarize the main results. First, we can see a reduction in the period of the emission associated with households. This is relevant for most of the goods, but we can observe also an increase in the emissions associated, for instance, with textiles and wearing, with metal products, electrical and machinery, and other manufacturing, for instance. We also see that intensities of the technology aspect has been the more relevant explaining this change in emission, and operating in the opposite side, we have, as usual, the scale of the economy, economic growth, and we have that the participation of the changes in the consumption patterns and in the distribution patterns are not relevant. But if we see here, we can also see relevant differences between the different goods, and we have seen also important differences between countries, even in the participation or in the representative of the different components. For instance, we see a change in the consumption pattern to a higher consumption of these goods, and all this is increasing the emissions. We have a reduction in the consumption patterns regarding this other group of goods, and we see, because I have here sorry. We see that in general, the scale factor is increasing the emission associated with household for all the considered goods. Here we have the changes observed and the participation of the different components for different regions in Europe and for different income groups. And the more relevant questions are the ones that I'm going to present. First, we see that the technological improvement have been the main drivers for reducing emissions, while the scale factors and the consumption patterns have contributed to increase this emission, particularly in the high income groups. We have seen that the consumption of the high-income groups, as has been also found for other countries, involves the large emission regarding or in comparison with the low-income groups. And we have seen that also the distributive effect differs by income group and at the strain intervals of the income. So for the high income and for the low income groups, this effect contributes to reduce emissions. We have seen also in the analysis that the largest relative decline in emission appears in this period for the low-income groups, because these falls in emission are related to the change in the origin and the technology of the consumption of the consumed goods. And we have seen that the largest reduction in emission compared to the beginning of the period are observed in the Nordic countries and also followed by the Mediterranean countries. We have seen we have seen that, on the contrary, the Eastern European countries present increases in emission that are even larger in the middle and in the middle-high income group. So the economic expansion in these countries is not offsetting the increases that are derived to or associated to the economic increase and the economic progress in these countries during the period studied. So this is, in general, what we have, the main characteristics that we have found for this period in Europe. And in the second part of the analysis, we want to to say we want to develop a scenario analysis and what if some parameters change in our model. One characteristic is that in general, we cannot attribute, or we cannot say that it's the same, the household consumption, and we cannot say that it's equivalent to disposable income, because consumption in the different income groups depends on the marginal propensity to consume. So for this scenario analysis, we are going to talk also about the changes in the marginal propensity to consume. And we are going to evaluate 3 different scenarios. The first one is we are going to assess the environmental effects of alleviating poverty by increasing income of those at the risk of poverty threshold, following the estimation of the Eurostat, set at 60% of the national median equivalent disposable income. In our case, this means to raise income in all countries for all of the households in the low income group and to go to the middle income group. And in this case, we are going also to modify the marginal propensity and consumption pattern, which are assumed to change after the increase in income. This will be the first scenario. In the second scenario, we will do the same, but in order to alleviate the environmental effects that we will be, we are going to redistribute income, and we are going to reduce the income in the high income group by the same quantity, the same total quantity that the increase in the income increase in the low income group. And so these 2 scenarios are comparable in the results. And the third scenario talks about effects of convergence in income, in consumption patterns between the different countries. First, assuming an average consumption patterns, and second, assuming the consumption pattern of one of the middle income group. Let me just present the main results. Oh, I don't see the screen because I'm seeing you. I don't see.
We can see it, Rosa. We can see it. We can see your screen. Yeah, we see it.
Okay. So if you look at the bottom of the table, you can see that in the first scenario, that is to alleviate poverty in the European Union, will increase emission, but just by 0.51%. It is true that the largest increases correspond to big countries or richer countries like Luxembourg, UK, Croatia, Hungary, and other countries with, in general, large emissions, surging emissions such as Germany, France, and Italy, even will reduce their associated emission because we are giving income to the low income groups, but this means more income, but also a change in the consumption pattern and a change in the propensity to consume. Income increase lead to more emission in some sectors, for instance, in petroleum, in chemical, non-chemical mineral products, transport and maintenance and repair, but also reduction in electricity, in gas and water, in construction, public administration and food sector in most of the countries. And in the second scenario, where we consider not only reducing, alleviating poverty, but also a redistribution on income, we consider reducing inequality and poverty through our income redistribution from the high income group to the low income group, with lead decreases in emission by 1.24%. So this is an opportunity to explore some kind of double dividend by reducing emission and poverty in Europe. Most countries, in this case, present declines in emission, like Greece, Germany, Netherlands, Italy, and Spain. And this reduction in emission is mainly associated with the falls in emission from food sectors, construction, trade, which are the most relevant in these countries. But we also, however, observe increases in emission in other countries, in other small countries, and also in the United Kingdom. And I don't know if I have time for the third scenario. I don't think so. In the third scenario, okay, we can see the presentation later if you go. We are going to talk, we address the possibilities of convergence in income in the different groups. First, assuming for all the countries in Europe, the consumption pattern of the middle income group. And if we do this for all the European Union countries, we obtain an increase in the total emission, in the global emissions. And this increase is mainly due to the countries, to some countries like Sweden, United Kingdom, and Austria, where the consumption pattern in these countries, in this middle income group, is more polluting than the average consumption pattern of all income groups. So in a second scenario, we say, okay, don't adopt this middle income group consumption pattern, but the average for this highly consumer and highly polluting countries. And in that case, we can obtain a decrease in emission by 0.90%. So this tell us that it's necessary we see the possibility of going through a more equal distribution on income that could be perhaps compatible with decreases in CO2 emission. But in that case, the specific policies should take into account or should try to meet the singularities of the different countries and the sectors which are the more important sector associated with the consumption of the middle income group or the middle class in the different countries. So final comments. As we know, consumption of households are important for global emission because households emit or pollute both directly and indirectly through the whole supply chains and represent more than 50% of the global emissions, as has been obtained in the literature. We have seen that in the last decades in the European Union, we have achieve a reduction in emission, but mainly associated with changes in the technological part, in the supply side, but we have not a clear impact derived from changes in the consumption patterns and the income distribution. So there is still room for exploring improvement in consumption patterns, mainly through the changes in diets, shorter supply chains, sustainable transport. That is what we are currently study. And we have seen that there is a possibility of make compatible different, or try to make compatible different sustainable goals. For instance, we have seen that it's possible to alleviate, to work towards an alleviation of poverty in these countries, increasing the income in low groups, in low income groups. This is true that will initially generate an increase in emission, But so there is a need of complementary measures to boost sustainable development consumption patterns. It's necessary to combine the supply side and the demand side policies to achieve these objectives. But we think that it's affordable for the economy, for the European economies, to increase income, to reduce disparities between income groups, and to control emissions, and to walk to this sustainable development path. We think that in that case, it's necessary to design income distribution policies and attending to the heterogeneity of the different European countries. But we think it's possible to explore patterns of compatibility between economic, social, and environmental goals. And this is the general positive result or positive idea of this work.
Okay, Rosa, thank you so much. Muchísimas gracias. Very interesting, well done exercise. I have two questions for you. There are more clarification actually. So number one, from your data, it's quite clear that the largest change was in technology, right? Mm-hmm. I'm very curious as to what extent that decrease in basically pollution per dollar unit of production is actually due to the delocation of those polluting companies abroad, outside of Europe. If you suddenly have that industry move to, let's say, somewhere in Asia or in Africa, directly your technology appears to have improved, but it's actually just a delocation of the company. That's the first comment for you. Secondly, I like very much your scenario whereby you try to reduce the income of the wealthiest category. Now, as you can imagine, they will not necessarily cooperate very much to make that happen. So what I'm curious is this: to what extent could the technology of the goods which are consumed by the rich should improve in order to reach the threshold you found related to reducing emission after you reduce the income of wealthy? In other words, to what extent the technology only of the goods consumed by the rich should improve to exactly reach the level you were able to set in your scenario number 2? What do you think?
Thank you, Sandy. Okay, I'm going to start with the second because it's a very, very interesting question that we are trying to address. Because we are trying to address, and it's not easy because it's to solve the model on the other side. We have done the exercise and we say, okay, what would be, is possible to calculate what would be the reduction in the technology coefficients in the rich economy to fulfill the or to adequate the changes associated to the change in income. I think is your question.
That is correct.
Yes, and it's possible. We have, okay, we don't have the, because we have been talking about this, I think that 2 weeks ago, and we don't have this is because the opposite is to achieve a reduction in the coefficients weighted, but the weight of coefficients or the supply side in all the model, and we have identified the total change that is around is of the same magnitude, and we have identified which are the sectors, the elasticity, which are the sectors that should be target. The more efficient sectors to reduce emission and to achieve the necessary reduction to balance the increase due to increasing income. Okay, and these are transport, and these are, I remember, electricity, I think, and I don't know the other one. So our idea is, okay, we are talking, because at the end, environmental policies in Europe say, determine several target sectors. And our question here is, okay, if we go to a reduction in poverty, it's possible to balance, to compensate the increase in this emission, just considering 3 or 4 relevant sectors. And if we provoke improvements in technology, in domestic technology in these sectors, it's possible to achieve zero increase of emission without increasing income. I have not the data, I have not the percentage, but we are working on this exactly.
Very good. Okay.
Okay.
Thank you, Rosa.
And regarding the first one about, yes, you are right, because in this paper we have identified the changes in the lambda components, in the pollution values, but we are in a multi-regional input-output model. So this lambda changed because changed the composition of goods, but also because changed the origin of the goods. But at the end, the goods consumed in Europe includes more than 80% of domestic production. So this localization is included in this change, but is not so relevant. I think that is not so relevant than technological change inside Europe. But there is a movement inside Europe from Mediterranean countries and Central European countries to Eastern economy, and this is why also we observe an increase in the coefficients corresponding to Hungary, Czech Republic, etc., Poland.
Perfect. Thank you so much, Rosa. We should collect more comments and questions for Rosa. If you have any, just unmute yourself, please.
Mm-hmm. Rosa, congratulations for your research, your work. I have just one question about the double dividend mechanism that you talk in the second scenario. Mm-hmm. Explain a little bit more about how you have implemented this double dividend mechanism in the second scenario.
No, yes.
Okay.
Perhaps it's just a claim, okay? It's an example of reducing, of compatibility between two goals. I just refer to this, okay? Okay. Just to say, okay, this is an example of one possibility of reducing poverty, and in fact to situate all households in Europe above the 60% of the average, etc., and also achieve a reduction in emission. How? Reducing high income in the countries.
Okay, but it was not simulating to tax or to tribute.
No, not now, not in this moment. No.
Okay. Thank you.
Okay, for the interest of time, Rosa, we're going to leave it to that. I am sure many other people have tons of questions for you, so feel free to reach out to Rosa anytime if you want to follow up on a conversation. And with that, we are going to move from Spain to Italy in order to listen to presentation number 2 by Simone Grabner. So why don't we have Simone pull up.
I can to share my screen.
Oh, wonderful. Yeah, I can see everything. So Simone is currently working in Gran Sasso Science Institute in beautiful Italy. So Simone, whenever you're ready, it's all yours.
Well, thank you very much for the introduction, and thank you very much for the invitation and all the organization. I know there's a lot of work behind it, but it's very nice to be in this group and to be able to present, especially as an early career researcher in this crisis time. These opportunities are really, really important for me. So thank you very much. And yeah, I'm in Italy, but my presentation is actually not on Italy or on Europe. It's on United States counties. So I'm presenting to you a part of my PhD thesis, which is going to be submitted in a couple of weeks. And the chapter is on interregional input-output linkages and relatedness as drivers for regional diversification of United States counties. So first, some background. What is regional diversification? So it generally refers to the development of a new industrial specialization, or could also be a new technological specialization in a region's portfolio of specialization. And why does it matter? Why is it important to study? So diversification is a process that is seen as very important to avoid any kind of lock-in, to avoid stagnation, to be able to stay ahead of competition, because you're continuously broadening and deepening and updating your industrial base. Then why is it important to look at diversification at the regional scale? So compared to nations, regions are much more dependent on a couple or a few industries because they're of course much smaller. So they're more vulnerable in case one of their sectors that they're specialized in are declining or are in a crisis. So diversification matters particularly at the regional scale. Now this literature on diversification has been developing over the last 10-15 years, and what has been found over and over again in this very empirical literature is that regions tend to diversify into new economic activities that are very strongly related to what they already specialized in. And this is then a term called related diversification. And industries, in this case, are then related if they demand similar capabilities or similar infrastructures or knowledge. And this is why related diversification is really prevalent, because regions already have a set of capabilities, and to build upon that is much easier than to gain a new set of capabilities. However, it's not unheard of. And when regions diversify into a new economic activity or industry that is unrelated to the existing set, it's then a process that is called unrelated diversification. And while this is not as common, there are some positive features related to it, namely jumps in industrial evolution, radical innovation are connected to unrelated diversification. So there's a large literature which looks at the drivers of diversification, and it has mainly focused on a variety of local factors. So the role of local institutions, of the innovation capacity, of the availability of technologies. But there are reasons to believe that also non-local factors might play a role. We already know that regional growth, innovation, and all kinds of other regional phenomena benefit from externally generated knowledge and capabilities. And there are also spatial spillovers from one county, from one region to another one. And there's already one study that looked at diversification, namely Anderson et al. 2013, and they found a positive relationship between openness and the introduction of new expert products. So non-local factors or non-local capabilities can reach a region through a variety of different channels. This can be commuting or migrant flows, also international trade and foreign direct investments, or what I'm looking at is intermediate trade, so input, output, and linkages. So the interdependence of industries is an important channel for knowledge diffusion and creation, something that already Leontiev formalized in 1936. And the reason for that is that buyers and suppliers have an incentive to share and to cooperate on innovations, because it creates mutual benefits for both of them. So then input-output linkages, if they're really a channel for knowledge diffusion and creation, they can provide the channel for external knowledge to reach a region upon which then new specializations may emerge. So one of the challenges though is in regional input-output data is really hard to come by. especially in the level, the spatial level that I'm looking at counties, there is no input-output tables on county level. So we have to proxy that somehow. And for that, I'm using a method that has recently been proposed by Han and Götz.
Sure, sir.
And can you hear me?
Yeah, you're good. You're good.
Ah, okay. And what I do is I look at the industry level input-output network, the national data, which is very easily available. So I reinterpret this table as a network, where the industries are the nodes and the supplier and buyer relationships are the connections among them. And in this network, you can calculate how important an industry is. And this is done by centrality measures. So for example, in this toy network that I have here, of these 5 industries, I identified hospitals and insurance as the most central industries because they are connected to all the other industries and they have a very strong connection as well. And then in a second step, I'm looking at the employment profiles of a county. So county A has a lot of employment, has a specialization indeed in hospitals and insurance, whereas the opposite is true for county B. So since hospital and insurance are more central in the national network, I can infer that also county A has more connections to other counties because it has highly connected local industries. That's the idea behind this proxy. So now I can go to my research hypothesis. In the first hypothesis, I'm just trying to understand whether these input and output relations, external relations to a county, have any effect on diversification, so on the development of a new specialization. In hypothesis 2, I'm trying to understand what's the relation between these input and output linkages and relatedness. So as we've seen, usually related diversification is the norm. But if a lot of external knowledge can enter in a region, maybe it relaxes the role of relatedness. So the second hypothesis and the idea behind is that the external knowledge might be different to what is already available to the region, upon which it can create new industries that are unrelated to what there is already. So that's my second hypothesis. Okay, then I'm going to be very quick here in the methods section, but I'm happy to answer any more questions afterwards. So I'm using employment data on over 3,000 counties and over 660 traded industries over the period of 1998 to 2017. And my dependent variable, so diversification, diversification refers to the entry of a new specialization. What I basically have to do to create this variable is understanding when there is a new specialization. For that, I'm using the location quotient. And as we all know, that's an imperfect measure because we don't have a cutoff value. But to get a statistically significant cutoff value for each single industry, I'm using Tian 2013 bootstrapping method. And then I observe the specialization status of an industry over a 5-year interval, which then provides me with a binary dependent variable, which is 1 if in year 5 there's a new specialization that hasn't been there 5 years before, and 0 otherwise. To measure relatedness, I'm also following the standard procedure in the literature. I'm using Hidalgo et al. Co-occurrence technique and a density indicator that then connects the industry relatedness to the local specialization profiles. Then for proxying the interregional input-output linkages, I rely on data on 66 industries, and then the county employment data on the same industries, according to the mechanism, to the idea that I explained before. Now, here's one important point to add. So I'm relying on centrality indices that try to tell me which of these industries are the most connected or the most important. And important or connected can mean many different things. And that's why there are many different centrality indices. And broadly, they can be divided into two concepts, namely global and local centrality in a network sense, not in a geographical sense. So in this toy network here, the node number 1 is the most central one in a local sense. Why? Because it has 4 connections, 1, 2, 3, 4. So highly connected in its immediate environment. But node 2 is the most central node in a global sense, even though it has only 1, 2 connections. But it's very strategically positioned because it connects this part of the network with this other part of the network. So while it has only 2 connections, it's easier to reach other nodes in this network via node 2. So it's very influential. So I'm using 3 different centrality measures in this work. One is closeness, which is a global measure, strength, which is a local measure. It simply adds up the value of those connections. And then entropy, which is also a global measure, and it reflects a node's diversity of connections, considering the whole network. And these variables I'm using in an econometric analysis, a simple logic model with 3-way fixed effects. Well, I guess let's go right to the results. So in the first hypothesis, I'm trying to understand simply whether there's a relation between this county centrality index, which represents interregional input-output linkages, and diversification. So here in this output table, in the first column, there's only relatedness density, and which represents the relatedness of one industry to another one. And it's highly significant and positive. And that suggests that related diversification prevailed, and result that was very much expected. And then in the second, third, and fourth column, I'm adding my closeness, strength, and entropy measures. And also they are positive and significant. And it does suggest that I can accept my first hypothesis, that the interregional input-output linkages really support diversification. And the relatedness coefficient is not really affected by this addition of the centrality measures. So we can accept hypothesis 1. Let's go to hypothesis 2. And there I'm trying to understand the interaction effect between relatedness and input-output linkages. So are counties that are more connected to other counties more likely to develop a new specialization that is less related to their existing set of industries? And here it proved to be important that I have these 3 different centrality measures. So to understand this hypothesis, you have to look at the interaction term. So here I'm interacting relatedness with the closeness centrality, and I have a negative and significant coefficient, and that suggests that closeness weakens the effect of relatedness. So indeed, counties that have a high closeness centrality within the whole network are more likely to diversify into an unrelated specialization. However, it's important to notice that relatedness density is still positive and significant. So related diversification is still prevalent. But counties with a high closeness centrality are more likely to develop a new unrelated specialization. The same thing we see also here in the relatedness density interaction with entropy, which is the second global measure. Same effect. However, we do not see that with strength centrality. Indeed, the interaction term is positive and significant, which suggests that strength centrality is actually re-emphasizing the role of relatedness. So here we can see diverging effects between the global measures, closeness and strength, and the local measure, entropy, and the local measure, strength. So my hypothesis 2 I can only accept in the case for the global centrality measures. Then I have a bunch of robustness checks where I control for urban-rural differences, inter-industry differences, also add a bunch of control variables, look at different time frames, and also try a linear regression. And they all confirm these results, namely that centrality in general is very positively related to diversification. But when interacting it with relatedness, I'm getting these different effects between the global and the local measures. So to wrap it up, in the study, I simply tried to understand the linkages among the relatedness and regional and input and output connections on industrial diversification in United States counties. And what I find is, firstly, unrelated diversification prevails. And secondly, and most importantly, is that interregional and output linkages, when they are proxied via this country centrality measure, do matter for diversification. But they matter even more if they're prominently positioned within the whole national production system, because then they stimulate regional diversification in general and unrelated diversification in particular. And that, I think, is the main takeaway of this paper, that it's not just important that a region has external linkages, but also who are those external linkages to? How are they positioned within the whole production network? So your friends of your friends matter, that kind of story. There, of course, are some weaknesses and future directions that come from this research. Of course, my proxy is not perfect, so it would be better to use directly regional input-output data. And that is, for example, possible in Europe, which is going to be my next paper, hopefully, where I'm using, where I don't need to proxy it anymore. And then I'm also don't exactly investigate what is the mechanism that makes knowledge diffuse through an input-output network. So that would be another question to go into depth. And the last one is that it would be interesting to understand whether it matters how related the local knowledge is with the external knowledge that is coming in. That could impact this research and these results. So thank you very much for your attention, and I'm looking forward to some comments and
yes, Simone, thank you so much. Grazie mille. Very interesting work, very well presented, and actually so relevant with a colleague of mine here in Illinois, Bill Ridley. We are looking at somewhat similar questions, so very nice. Two questions for you. Number one, it turned out that the Department of Transportation here in the US provides you with some state-to-state data related to basically the trade of some goods. It's not as detailed as the 600 and some different commodities you're focusing on. I think we're looking at roughly 15 groups, but at least those are observations. And they could eventually, to some extent, help you calibrate a bit your results, in a sense that counties are obviously the sum of, states are the sum of counties, right? So something I can share you the link at a later stage. Secondly, I noticed that in an early part of your work here, you're using location quotient as a way of disaggregating what's happening from the national level to the more local level. I was curious as to whether using not only LQ, but also CI-LQ, cross-industry location quotient, could be a way of research, because if you do that, you actually account for the local presence of an industry, not only that industry itself, but also how it relates to the presence of the different industries that it's purchasing from. So maybe the CI-LQ could eventually, be part of those robustness checks. So just basic elements here.
Okay, thank you very much. I knew about the state-to-state input-output data. I'm not quite sure yet. I'm still thinking about how I could use information that is provided there. I did not know about the cross-industry location quotient. thank you very much. I'm gonna have a look at this.
Just to clarify, the data I was mentioning are actually trade flows. It's not an IO system. It is just trade flows of that going from I to J. I'll send you the link and you can see if it can be relevant for you. Why don't we collect?
Thank you very much.
Yeah, sure, absolutely. Why don't we collect more questions and comments for Simone, please?
Simone, this is Jeff Hewings. Thank you very much for a nice presentation. I've got a number of suggestions I'll send you in an email, but just a couple of thoughts to sort of parallel what Sandy was saying about alternative data. We have a very nice annual county-to-county migration data series that comes from the Internal Revenue Service. Mm-hmm. And I think that's one channel that you might want to consider, the degree to which information is moving not just through the proxy of goods and services, but actually through the movement of people. And that's a very nice time series. So, and it's publicly available, so you could use that. And the second thing on your sort of using sort of graph theoretic measures, I would encourage you to read some of the work of Ronald Burt. And he's come up with this notion of structural holes. And the sort of link to your work is the idea in your diagram where sector 2 was only linked to 2 sectors, but connected the whole network together. Well, what he focuses on is how the absence of one link can dramatically change that network structure. And I think you will find that to be very, very valuable in trying to elucidate some complexities in your work. So I'd be happy to send you a reference to his work with my email. Thank you again for a very nice presentation.
Thank you very much for the suggestions. I didn't know about the county-to-county migration data, and that can really complement that analysis, I think. And about the work, Ronald Burt, right? The thing with the input-output networks is that they're really highly connected. So it's that almost every industry is connected to every other industry. So if one falls away, I wonder what happens. Maybe it's not that relevant, but I'm definitely going to read the work. Thank you very much for the suggestion.
If I can go next, this is Mike Lahr.
Yes, Mike, go ahead.
I have a couple of things. One is your whole thing got me thinking about something I just read about, which is the friendship paradox in sociology, which is that most people have fewer friends than their friends have, which is a strange thing. So I'm just wondering if this is also the case in networks like this, particularly given the zeros, and the zeros depend on your level of aggregation. If you go to the full 405 sectors in the US table, there's lots of zeros. If you go just to your 66, it's very different. Anyway, my point is, it could be really interesting if you could show that this was also true for industries. That is, industries that are highly connected are highly connecting everyone. So the ones that you are connected to are just more connected than you are. It may be a kind of interesting thing to do for future research, not here. I just think it was something that occurred to me that it's one of those strange things we always hear about in nature. It kind of deals with the same thing as, the average number of legs is less than 2 that people have, just because people. Oh, yeah. So anyway, it has to do with that kind of strange thing. Just was the thought, and otherwise it was a nice presentation. I'm surprised that Sandy didn't try to influence you to use the industries as weights in a spatial regression, but that's another thing that he.
I would not dare, Michael. I wouldn't dare. It's IO.
Okay.
So.
Okay.
More comments, more questions for Simone.
Well, first of all, thank you very much for that comment. I think that's I really like networks, it appears. And I think that would be really interesting to look at just at the industry network like these 600 industry input-output tables that are available. And what I do find though in this network is that they are scale-free. So we have this relationship that there are very few industries with a lot of connections, and it goes down. So most industries have few connections.
The paper was by Scott Feld in 1991. I don't know what journal it was in, just so you can look it up.
Thank you very much.
Google, yeah.
Okay, we have time for one more question or comment for Simone.
If I could ask a question,
sure.
or a couple at least. So first of all, I like that a lot. So thanks, Simone. You had a bullet point in your conclusion about trying to dig deeper on what are the mechanisms for knowledge spillovers through IO linkages. And I only mentioned this as a trade guide, is that there's a lot of literature in the foreign direct investment field on those linkages. So I would seek out a citation like Duarte, who she's written a few papers on this in the FDI context. So that could be a good direction to go. My second question is about your results, and I think I missed it. Was that are you running a Poisson model, or do you have a count on your left hand side?
It's just a logit model.
Just a logit. So two questions. Are you concerned at all about that R squared of about 0.06? And connected to that is, given that you have a panel of county level data, is there anything stopping you from using some sort of county level fixed effects?
I do have county level fixed effects. So I have three weighted effects.
State.
Did I write state? No, okay, sorry. That was a spelling mistake. It's definitely county level.
I see,
county,
okay.
industry, and year. So about the R squared, yes, I am a bit. I mean, with these very detailed region industry regressions, it's nothing uncommon. So I've seen that a lot in related literature, and nobody discusses it. So I didn't put too much thought in it.
Per se, it's not an issue. So
yeah,
it's just strange because if you have those individual county fixed effects, I would imagine you would be capturing a lot more of the variation there. But on its own, it's not this crucial shortcoming. It's just kind of curious. Yeah,
I agree. Yeah, no real explanation for that, but it's odd.
But going with that, with 7 million observations, almost everything's going to be significant or not. And this makes me worry more about your significance, just because you have so many observations.
Yeah.
It's not clear, given the low R, what pseudo R, what you really have.
Yeah, I thought about doing like a robustness check with fewer industries, just use so fewer industries are gonna decrease the number of observations a lot. Yeah.
Or some sort of county industry fixed effects, perhaps.
So interacting counties with industries and then making this a fixed effect.
Yeah, maybe worth a shot, but just things to think about. And again, I really enjoyed the presentation, so thank you.
Thank you very much. Good to hear.
All right, Simone, I think a lot of good ideas to think about, but only after graduation. Focus on that soon. I think you mentioned earlier that you're about to defend. So congratulations, Simone.
Yes.
Very interesting work. And Rosa, Simone, thank you very much to both of you. Gracias, grazie mille. And I hope to see all of you next week, same place and same location. Bye-bye, everyone. Thank you.
Thank you.
Bye-bye.
Bye-bye. See you next week.
Bye. See you. Thank you.